Today we will study and prove the extended law of sines. Law of sines, more generally known as sine rule, is a theorem which is frequently used in trigonometry. It is of great importance, but always we find this law is given in various books in a very truncated format. Mostly it is given as a upon sine a is equal to b upon sine b equal to c upon sine c equal to some constant k. But in this extended law of sines, we are studying about the constant k. So the theorem states that for a triangle ABC with circumradius r, a upon sine a is equal to b upon sine b equal to c upon sine c equal to 2r. Here the triangle ABC is referred as a customary triangle. So it follows the general notation of drawing a triangle. So when we are saying that a customary triangle ABC, this means the vertices of triangle are in anticlockwise direction and the opposite sides of each angle is denoted by a small letter to the corresponding angle. For example, if angle A, that is denoted by capital A, then its corresponding opposite side will be BC and it is denoted by a small letter a. So we will prove this in this lecture, the extended law of sines, that is a upon sine a is equal to b upon sine b equal to c upon sine c equal to 2r. Generally, there are three types of triangle. The first one is say acute angle triangle. In this triangle, each angle of the triangle is less than 90 degree, hence the name acute angle triangle. Another one is obtuse angle triangle, that is one of the angle of a triangle is greater than 90 degree and it is known as a obtuse angle triangle. And the third one is called as a right angle triangle. So these are the classification of triangle based on their angles. So we will prove this extended law of sines for acute angle triangle and then we will extend it to obtuse angle triangle and right angle triangle. So consider the acute angle triangle ABC with usual notation or the customary triangle ABC. So we have triangle A, B and C. So the opposite side of angle A is denoted by letter small a. Now this triangle ABC is a circumscribed. The circumscribing circle is having radius equal to r and the center is O. That is circumcenter of the circumscribing circle is O. So here we are drawing the dotted line, that is CJ is passing through the center O and therefore it is a diameter of the circle. CJ is a diameter, therefore its length will be 2 times the radius, that is 2r. Also the angle CBJ is equal to 90 degree because this angle is inscribed in a semicircle and therefore it is half of the arc in which it is inscribed. So therefore it is 180 divided by 2, that is 90 degree. Therefore angle CBJ is equal to 90 degree. JBC sin J is equal to front side, so that is equal to BC divided by the hypotenuse, that is JC. So that is equal to A divided by 2R. Now if we look in this figure, we find that the angle A is inscribed in the same arc as the angle J. Therefore, angle A is equal to angle J. Sine A is equal to A upon 2R since angle J and angle A are equal. Therefore, I can write A upon sine A is equal to 2R. Now, if we repeat the same process for other angles B and C, we will get two similar relations, that is B upon sine B, B upon sine B is equal to C upon sine C is equal to 2R. And therefore, we have proved that A upon sine A is equal to B upon sine B is equal to C upon sine C is equal to 2R for acute angle triangle. So we will examine the other two triangles, that is obtuse angle triangle and a right angle triangle, and then we can conclude our extended law of sines. So the next one is obtuse angle triangle. So in this case, the similar construction is done where the angle A, the angle which is under consideration, is obtuse angle triangle, obtuse angle. So this angle BAC is a obtuse angle triangle, and we have made the similar construction, that is we have drawn a line passing through the center of the circumscribing circle, that is circumcenter is O, join C with O and extended it to J, and then we have joined the line J with B, and this construction we are showing by a dotted line. So now again the angle JBC, so that is angle JBC is equal to 90 degree because it is circumscribed in a semicircle. Therefore, angle B will be 90 degree in triangle JBC. Therefore, applying the sine rule here, we can write sine J is equal to BC divided by JC. That is equal to A divided by 2R. A upon sine J is equal to 2R. Now in this case, if we look the points A, B, C and J, we find that the quadrilateral JCAB is a cyclic quadrilateral. The property of the cyclic quadrilateral is that the opposite angles of a cyclic quadrilateral are supplementary to each other. So this means angle in case of quadrilateral JCAB, angle J plus angle A, which are opposite, so it will form at a 180 degree. Therefore, J is equal to angle J is equal to 180 minus A. Therefore, in the above equation, in case of a obtuse angle triangle, I can say A upon sine J, we can write 180 minus A. Since J equal to 180 minus A, that is equal to 2R. A upon sine A is equal to 2R. Here, sine 180 degree minus A is equal to sine A. That is, we have to write here sine theta is equal to sine 180 minus theta. So therefore, we can write sine 180 minus A is equal to sine A, and therefore A upon sine A is equal to 2R. And similarly, we can also prove for the angles B and C, and therefore we proved that A upon sine A is equal to B upon sine B is equal to C upon sine C is equal to 2R. Now the last triangle is a right angle triangle. Here the angle under consideration is A, so therefore this angle is 90 degree. So the angle A is 90 degree. So angle BAC is equal to 90 degree. Now the circumscribing circle is having radius R, and in this case sine A is equal to sine 90 degree. So that is equal to 1 because angle A is 90 degree. Therefore, sine A is equal to opposite side, that is A, upon side BC, or the diameter of the circumscribing circle, so that is 2r. And as in this case A equal to 2r, so that is 2r upon 2r, that is equal to 1. Therefore, sine A is equal to A upon 2r, A upon sine A equal to 2r. And for other cases, we can say B upon sine B upon sine B equal to C upon sine C equal to 2r. Now we have proved the result for the three different triangles, that is acute angle triangle, obtuse angle triangle, and right angle triangle. Therefore, we can say in general we have proved for any triangle ABC, A upon sine A is equal to B upon sine B is equal to C upon sine C is equal to 2R. So this theorem is known as extended law of sines, because in most of the book it is given as A upon sine A is equal to B upon sine B is equal to C upon sine C. In some books it is also given as sine A upon A is equal to sine B upon B is equal to sine C upon C. In some books it is given as A upon sine A is equal to B upon sine B is equal to C upon sine C is equal to K. Or it is also given as sine A upon A is equal to sine B upon B is equal to sine C upon C is equal to K. The constant is a confusing, and it doesn't represent, the constant K doesn't represent any geometrical interpretation. But in case of extended law of sines, we have proved that the constant, that is A upon sine A is equal to B upon sine B is equal to C upon sine C is equal to 2R. So that represents the diameter of a circumscribing circle.